Hey guys, this is Don Crowley. I'm going to run you through my CSC 578 final project, predicting temperatures from a multivariate time series. The first thing I did was a little bit of data exploration. You can see here that most of our data moves in a similar way. It's kind of goes with the seasons. Um, I also wanted to look at the correlations between variables. You can see here some of the variables are pretty highly correlated. I found a better way to look at this. It was the SNS package. Pretty interesting to see that it gives you the distributions of each variable, and in addition, you can kind of see the correlations. For example, the rho and the temperature are pretty highly negatively correlated, whereas the RH and the VPACT were much less correlated to one another. I looked for multicollinearity. I ended up not doing anything about this, but there were a couple variables with pretty high correlation. In an ideal world, I probably could have dropped a couple of these. Um, you can see here the correlations. All right, now to our model. So the base model I started off with was a one LSTM layer with 50 nodes. I ran it for 30 epochs or 50 epochs. You can see here's my graph of the training and testing. Just looking at the graph, it looked like the test error was creeping up. So I had a little bit of overfitting after 27 epochs. I ran it again, stopping at 27 epochs, and I came up with a better error on the test set. The next thing I did was I tried a dropout layer of zero point 0.2 on the dense node. Dropout layer is something we can also use to help with overfitting. Uh, it looked okay from the graph of the error over the epochs, but I ended up with a higher RMSE. The next thing I did was I tried a much more powerful LSTM layer. This time I had 250 nodes. I ran it for 50 epochs, and I used a dropout of 0.25 on the dense layer. This ended up working out reasonably well, so this was an improvement, lower RMSE. Improvement probably just due to the overall power of the LSTM layer. Next thing I did was I decided to make it even more powerful. Ran 3 LSTM layers plus an additional dense layer with 50 nodes. So my patience equal to 5. Basically, the idea behind patience is if the testing error doesn't improve over 5 epochs, the training will stop, and that's your model. So this ran for 23 epochs before it stopped, and it was actually not an improvement. So I was kind of surprised by that, given that it was a more powerful model. Um, Next thing I did was I had a dropout to the LSTM layers and gave a slightly longer leash for early stopping. I set my patience at 10. Dropout to the LSTM layers helps to prevent overfitting. Um, so I thought I could let the neural network kind of train for a little bit longer. This ended up working out pretty poorly. You can see here I had a pretty bad overfitting problem. My testing set crept up quite a bit while my training set kept decreasing. I played around with this a little bit. I used a couple different dropout percentages, and nothing worked especially well. So from this point on, I cut out the dropout from my LSTM layers. Next thing I did was I stacked 2 LSTM layers, no dropout. Set my patience equal to 10. Uh, this was another improvement. So simpler is better in this case. As far as dropout goes, I want to try recurrent dropout next. Recurrent dropout uh, is a dropout within the LSTM layer as opposed to before or after. Uh, this worked better than the normal dropout, but it still wasn't an improvement on my best model yet. Um, Next thing I wanted to do was bidirectional RNNs. So bidirectional RNNs It takes data from before and after to help the prediction. I thought this would work really well because just the way the temperature is set up, it seemed like weather conditions before would be related to weather conditions after. Um, this model didn't do poorly, but still wasn't an improvement, which I was pretty surprised by. I also tried smaller but more numerous layers, so a bunch of LSTMs equal to 10. I kept the bidirectional in there, another dense layer. This is a pretty complicated model. Ran for 45 epochs before stopping. Still not an improvement on the RMSE. The final thing I did was I threw in some GRU layers, and I tried using Natum instead of Atom. The idea behind that was Natum as as an optimizer. So the Natum optimizer has a decay written into it, whereas the Atom does not. So my thought was that a decay might help the model run longer. Have the learning kind of get smaller and smaller as we went along. That didn't work at all, so I ended up not using it. It was really slow, didn't converge. So I actually did end up using the Atom optimizer here after all. Uh, so this ended up being my best model of the bunch. Got an RMSE error of 0.735. It worked best on the Kaggle data. Um, Basically, my conclusion was that I just used 3 layers, 250. So it was a pretty simple model, but pretty powerful as far as number of nodes. That was kind of my best overall neural network from the project. A couple other things I tried. I could not get the set stateful equal to true. Um, so if you have any recommendations on how that would work, this was the error I got. I also couldn't get the convolution to work. I wanted to use it as a first layer in the neural network, and I just couldn't get the right dimensions. So I'd appreciate feedback on that. All right, thank you.